I know we were gonna do delete now, but I kind of want to do toString because toString is kind of the same thing as delete, but just slightly easier. Okay. Um, all right. So big things here. We've talked about intimate relationships before, and I know it's a Title IX violation. Joking. It might be. Intimate relationships, right? And intimate relationships, well, the most intimate relationship, right? And I know some of you are watching The Bachelor or The Bachelorette or all these other shows, but those aren't intimate relationships. The most intimate relationship we've seen so far is between arrays and for loops in our entire lives, okay? In any arena, it's arrays and for loops, right? They go together like, well, arrays and for loops because there's no analogy that fits that because they're the most intimate of partners, okay? So yeah, arrays and for loops. But there's a couple that's nipping at their heels, okay? And this couple is linked lists and while loops, okay? And so it's like both of these things are battling it out for the it couple of, what is it, 2021, all right? I mean, there's the classic arrays and for loops, splattered across Entertainment Weekly, and then there's the classic linked lists and while loops, splattered across Us Weekly. Who's the it couple? Well, check your newsstands or check the rest of this video because we'll talk about it. Now, the reason arrays and for loops are so intimate, okay, other than the fact that they just belong together and are soulmates, is because arrays have this idea or this notion of a length that you know from the beginning, okay? You know from the very start of it. Arrays have this notion of length, okay? That's being kept track of. We could keep track of the linked list length. Every time you add something, you could say length variable plus 1, and every time you subtract something, you could say length variable is minus minus, right? Every time you delete, or equals length variable minus 1. We could do that. But it's not strictly part of the linked list class that we created, okay? So linked list the idea is that linked list should work even if you don't have a length variable defined, okay? And so here, since we have a length, right, and let's call it my array, let's say the instance of our array is my array, right? We don't even have to know what type of array it is. It's always the same, right? And our index value equals 0, index is less than my array dot length, right, index equals index plus 1. We've done this so much that you probably have it tattooed somewhere and you just look at it, right? And so, cool, right? Get a room arrays and for loops, jeez. Okay, so now let's talk about linked lists and while loops, okay? So if we don't have a length, how do we know we've gone through, if we want to cycle through the linked list? For example, in our toString example, right, what we're going to do, so what needs to be returned if we want to convert this linked list toString is that if we have the empty list, right? So let's think of the first case, the empty list, we want to have this string returned, okay? And this is the empty case, right? But in the non-empty case, like, we have one node 5 in it, right? We want head to point to 5 to null, and that's the string we want returned, okay? And so we have a string head with an arrow to it. You can make the arrow with the dash and the little caret The dash is to the right of 0, and the little caret is to the left of the question mark. 2 to the left of the shift, the right shift. Okay, and so that's how you make this arrow. You can do it with 2 characters. All right, so head goes to 5, goes to null, and that's if we had 5. Let's say we had the number 5 and 7 or something like that. Then we would do this: head 5, 7, null, right? Because 7's the last thing in our linked list. Okay. So far, so good. All right. Notice that when we hit null, we are done traversing this linked list. Okay. So even though we don't know the length of it, we do know when we're not going to traverse, and that is when we get to null. Okay. So we can start going through our linked list, and when we get to null, we can be like, well, we've gone through every node of the linked list when we get to null. So a while loop, all right? A while loop is, so we use a for loop when we have the numerical limits, of the loop. And we use a while loop when we don't know when the loop will end. Okay? And in the linked list case, since we don't have the size of the linked list, or let's assume we don't have the size of the linked list, typically what we do is we will loop with the while loop, all right? And then when we hit the null value, we will call it a day, okay? So how does that actually manifest itself? Okay, well, let's think about it, all right? So what we're gonna do is we have, let's say we had head, and let's do the end case because it's more interesting than the null case, the empty list case, I mean. Let's say we had the following. Okay, so we have 3 items in this list. We've got 5, we've got 6, and we've got 2, and 2's next is pointing to null. 5's next is pointing to this node with 6. 6 next is pointing to this node with 2, and then 2 is pointing to null. Okay, so we've got a nice little list here. All right, and how do we traverse this thing? Okay, how do we go through every element of this thing? Well, if I said something like this, right? If I said, okay, what that'll do is that'll make current a shallow copy of head, right? Current is now a shallow copy of head. Okay, meaning current and head are pointing to the same object in memory. If I change current, I'm changing head, and if I change head, I'm changing current. Okay, and now think about this. All right, if I say while current does not equal null. Okay, and this is something you're going to see over and over and over again. Just like with arrays and for loops, you saw that format of for index equals 0, index is less than the array dot length, index equals index plus 1. We've seen it maybe 3 billion times. I mean, they really are the it couple of 2021, right? You're going to have the same thing happen here, all right? You traverse a linked list, That's the way you traverse a linked list. Now, can it change? Can we modify it slightly? Like, we don't want to go all the way to the end. We want to go to the second to last one. And so we've got to mess with this a little bit. Absolutely, right? We can modify it slightly. But this format is going to be the same. Just like in the for loop, right? In bubble sort, we were like, well, we don't want to go all the way to the end in bubble sort, because if we go all the way to the end, we're going to overrun the end of the array. Same types of things can happen here, right? If we're looking at the next node and the previous node, we might have to do something special with that, or have two things running through this or anything. But it's always going to be something like this, okay? All right, and then inside here, okay, we are going to say, so current is head, right? And we could even do, like, if you wanted to, system.out.println. That's not toString, by the way. toString has to return a string, okay? But system.out.println is not the right thing you're supposed to do, but we could do it. And I could say it's close to what you have to do, so why don't I do it? Current dot data, right? So current's a node. Right now that node's referencing the same thing as head, and if I say system.out.println current.data, what'll print out to the console is 5. Okay? Cool. So far, so good. Okay? And now, the other thing is, if I say current equals current dot next, okay, think about that for a second. What would that do? So current is referencing this node right here. Current dot next, well, that is whatever the next of this node is, which is this node over here. So current equals current dot next jumps current one node over. It makes current, well, don't do that. It makes current now reference that node. Okay? Does that make sense? Let's do it again. All right, so at the beginning, we created a random node and set it equal to head in a shallow copy. Okay? Then we said, well, current does not equal null. Clearly, current does not equal null here. Okay? So we say system.out.println current.data. It prints 5 out to the console, right? Remember, we're not printing out to the console in toString from the toString function. We're returning a string. Okay? So your code will look like this, but it won't be exactly like this. Okay? And then we say current equals current dot next. Okay, well, the next of current is a node. That's good because current's a node, right? And it's the node that our current node is referencing in its next field, right? So we're gonna shallow copy into current the next one. Okay, so current is a shallow copy of its own next, right? I know, sounds weird, but you can see what's going on here. Well, then what'll happen? Okay, that's cool. So then, does current equal null? No. And so we're gonna system.out.println current, which will print it out on the next line, right? And that's 6, current.data, I'm sorry. And so that'll print out 6, okay. And then we're gonna say current equals current.next, which will shoot current over here. So now current is pointing to 2 over here. And does current equal null? No. So we can system.out.println current.data, which equals 2. Okay, so we've printed out 5, 6, and 2. And then we're going to say current equals current.next. Well, the next of current is equal to null. All right, so now we kind of get it, right? Because now current equals null, okay? And we kick out of the while loop, all right? So now we kick out of the while loop, all right? And we're done running through this whole linked list at that point, okay? So that's how we run through a linked list. Let me grab another pen just to make it abundantly clear. The elements of running through a linked list with the while loop, right? The up and coming it couple of 2021. All right. So the first thing we're gonna do is we make current equal to head because head is the first node of this. Okay. We can say while current does not equal null, okay, because we know if we hit null, we've gone to the end of the linked list, okay? We can do whatever we want, you know, at each node, some sort of processing at each node, right? And then we can say current equals current.next to get us to the next node, okay? So this is how we start, okay? This is where we end, and this is how we update. Okay? Current is our control variable. And it's the same kind of deal. Where we end is the condition where we end, right? And where we start is, well, we're going to start at head because that's the beginning of the linked list. Notice there is no indication that I know the length of this linked list here, right? It is length agnostic, all right? And so I don't know the length. I don't need to know the length, because I know the second I hit that null, it's over. Sanity checks, okay? Would this work for a empty list, okay? So think about it. Would this work for an empty list, all right? Would this work for a list of one element? Would this work for a list of two elements, okay? And we'll ask some questions about that below, all right? So, yeah, check it out. The it couples of 2021. That joke's never getting old, ever. And I'll see you next video.